in this question here, it says the angle of elevation of Robert's kite is 40 degrees. Okay, so that's this angle right there. After walking 20 meters while reeling in the string, Robert finds a new angle of elevation to be angle ADB. Now, the first thing we're going to do here is figure out what ADB and DAC are. Now, ADB is going to be this angle right here. And I can tell, because this angle here is 110, I can tell how to get angle ADB from that, because those two angles together should add up to 180. So angle ADB should equal 180 degrees minus 110 degrees, which means that angle ADB would be 70 degrees. So this angle here is 70 degrees. Now, what is angle DAC? Well, DAC, similar sort of an argument here. The three angles inside that triangle, and that's obviously not a right angle triangle, is going to be, but the angles here, DAC will be 180 degrees minus 110 degrees minus 40 degrees. Okay? So it's going to be 180 degrees basically minus 150 degrees, which will give us 30 degrees right there. Now the next question says determine the length of the string AD. So that's, and I'll draw a blue line here. We're looking at that right there. Determine the length of the string AD after Robert has walked 20 meters. Okay, so what we're going to do is, basically what we've got here is a triangle. I know that this is 30 degrees, this is 110 degrees, and this here is 40 degrees. I know that this is 20 meters, and I want to figure out what that side length is. Well, quite honestly, that's just the sine law. I have a side pair angle. I've got the 20 and the sine of 30 degrees. Now, it's a little bit weird to see that because it's a little off kilter there. It's shoved over. But 30 and the 30 degrees and the 20 meter side are opposite each other. And then that's going to equal x over the sine of 40 degrees. Okay, so that means x is going to equal, when I multiply this through, 20 times the sine of 40 degrees all over the sine of 30 degrees. Okay, so on my calculator, 20 times the sine of 40 divided by the sine of 30. And I get that this is roughly 25.7 meters. Now, I'm going to leave that number in my calculator because I suspect I'm going to need it in just a moment. Because the next question says, determine the vertical height AB of the kite from the ground. Okay, so now I can focus my attention just on this one triangle here, this smaller triangle to the left. It's a right angle triangle. I know that this hypotenuse is now 25.7 meters. What I want to figure out is the height of that kite. But in that triangle, I know that bottom angle. I know the hypotenuse. I'm looking for the opposite side. That is the sine ratio. And so that's going to be y over 25.7. So when I multiply that up, it'll be 25.7 multiplied by the sine of 70 degrees. I'm going to leave the 25.7 blah, blah, blah that I have in my calculator. I'm going to use the whole thing. So I'm going to multiply that number by the sine of 70. I'm just going to let my calculator do all the work for me. And when I round that to the nearest tenth, I get that it's approximately 24.2 meters up.